So today we are talking about functions again and whether or not you can predict the output of a function. And this time we're going to talk about something that's a little bit more practical first. So as you've studied relationships between input and output values, but what happens when the relationship gives you unpredictable results? What happens when you cannot predict the output for a given input? Today you will study this situation and will be introduced to the quality that makes a relationship a function. So basically we're going to talk about what is a function, and then what are some things that are not functions and why. The soda machine. This is one of my favorites of the whole year, one of my favorite discussions. The soda machine at your school, right, like we're going to have a soda machine at the school, offers several types of soda. There are 2 buttons for your favorite drink, Blast, while the other drinks, Slurp, Lemon Twister, and Diet Slurp, each have 1 button. Describe the input and output of the soda machine. So the input are all of the different possible buttons, and the output would be different types of soda. So possible types of soda. I don't know what that little squiggle was at the end that I started to do. While buying a soda, Ms. Whitney pushed the button for Lemon Twister and got a can of Lemon Twister. Well, that's the way it should work, right? Later, she went back to the same machine again, pushing the Lemon Twister button, but this time she got a can of Blast. Is the machine functioning consistently? And I think that's a big no. It is not. And why or why not? Well, we cannot predict the output when the Lemon Twister button is selected. So when the output is unpredictable, you get a machine that's not functioning. When Brandy pushed the top button for Blast, she received a can of Blast. Her friend Miguel decided to be different and pushed the second button for Blast. He too received a can of Blast. Each of them asked 5 friends to push the 2 Blast buttons, and all they got were the same result, a can of Blast. Is this machine functioning consistently? We would say yes. Why or why not? Based on the information, we can predict when we push the Blast button, we are going to get a can of Blast. And one of the things I'm going to do here is write based on this information. We can't guarantee that every single time it's going to come out Blast, but they've done enough samples at this point where it seems like it's working predictably or consistently. So we would say based on this information, we can predict when Blast is selected, the output will be Blast. I'm trying different pens because I'm not real keen on the sound, so I'm probably going to switch it up every now and then. All right. When Lutfi pushed a button for Slurp, he received a can of Lemon Twister. Later, Taisha also pushed the Slurp button and received a can of Lemon Twister. Still later, Taisha noticed that everyone else who pushed the Slurp button received a Lemon Twister. Is the machine functioning consistently? Now, the question here, is it consistent? Yes. Are we happy with it? No. But is it functioning consistently? Yes. Why? Based on this information, we can predict pressing Slurp will give us Lemon Twister. Functions. In a relationship like the soda machine, we want the output to be consistent and predictable. When it is, we say that the machine is functioning properly. Examine each of the tables and graphs below that show different inputs and their outputs. Decide if the relationship could be describing a machine that is functioning properly. So if I push button 1, I get sticks. Notice this is sort of a knockoff on the Candy Twix. If I push button 1, I get sticks. Button 2, M&Ns. Button 4, M&Ns. Button 2, duds. Button 3, duds. Well, button 2 gave us M&Ns, and then later button 2 gave us duds. So we would say no, button 2 is unpredictable. That's a problem. Sometimes it's working, but other times not so much. Sorry about that on the handwriting. Button 2 is unpredictable. All it takes is 1 for us to say that it's not functioning properly. All right, input. If my input is 7, I get an output of 6. Input is -2, I get a -3. Input is 0, 4. Input of 4, 2. What I'm looking for is that each input has only one output. So 7 always gives us 6. -2 always gives us -3. So we're going to say, yes, it appears to be functioning properly based on the information. Each input has only one output. And that is the phrase. Each input has only one output. That's what we're looking for in a function. Now, the next one, you will notice when you look at it quickly now, there's a problem. There is an input of 2 with an output of 9, and over here there's an input of 2 with an output of -8. So we would say that this is not functioning properly because when x equals 2, it has 2 different outputs. That's a problem. That's supposed to be an ENT. You know what? I've got to slow down on my handwriting here. I'm not used to writing with pen, actually. A relationship between inputs and outputs is called a function. If the inputs and outputs behave like the soda machine that's functioning properly. So normally we would talk about inputs and outputs. Other things that would work this way would be those little machines when you leave the grocery store where you put the quarter in and you turn the knob and it's a gumball machine and it gives you a gumball, and then you do it again tomorrow and it's a gumball machine and you put your quarter in and you turn the knob and it gives you a gumball. It's functioning properly if the gumball machine gives you a gumball. But if all of a sudden you put your quarter in the gumball machine and it gives you a bouncy ball, that's not functioning properly. The same thing can be said for graphs. Examine each of the graphs and the table below. Compare the inputs and outputs and decide if the relationship could be a function. So this one here, what we're looking for is an input of -3, there's only one dot. So that's good. An input of -2, only one dot. Input of -1, only one dot. Now there doesn't happen to be a dot over or below the 0, but that's okay. All we care about is that for each input that is in the picture, there's only one output. So we would say yes to this one. Each x value has only one y value. That's just another way of saying each input has only one output. Now, this snail shell looking design, you can pick anywhere on there pretty much and find if you draw a vertical line, it's going to hit this curve in more than one place. So one of the things we do is called the vertical line test. And in this case, we would say, this does not pass the vertical line test because it hits more than one place using a vertical line. Another way to say that, no, some x values have multiple y values. Now, the example I did here was 1. If x equals 1, y might be 2. If x equals 1, y might be -1. If x equals 1, y might be -3. There's 3 different outputs when x is 1. So does not pass the vertical line test, has more than one output for an individual input, or some x values have multiple y values. Now, if we look here and we look at our inputs, -8 gives us 11, and down here, -8 still gives us 11, 4, 11, 6. Yeah, so for all intents and purposes, each x value has only one y value. So we could say, yes, each input has only one output. And I just copied that phrase from up above, but that really is the phrase. Or you can say each x value has only one y value. And this curve, if I were to draw vertical lines all over, you'll notice that no matter where I draw the vertical line, I'm only hitting the curve in one place. So I hit it here, I hit it here, I hit here, I hit here. It is passing the vertical line test at all locations. So you can say it passes the vertical line test. That's another acceptable answer. Passes the vertical line test. Now that answer would not make sense if you were given a table because there is no graph for it to pass the vertical line test. But if you're given a graph, perfectly acceptable answer to say that it passes the vertical line test. Jade noticed that the line graphed at right is a function. Hey, I think all lines are functions, she exclaimed. Is she correct? Is there a line, something linear, straight, that you can draw that would not be a function, something that would not pass the vertical line test? And there is. So is she correct? No. If you were to graph a vertical line, so if you graphed the equation x equals 2, and so you had all these points where x equaled 2, that would not pass the vertical line test. So vertical lines, which are linear, do not pass the vertical line test. All right. And there's a follow-up question on here. Think of a type of machine that you use on a regular basis and describe how it also functions. ATM machines, you plug in how much money you want, it better spit out the same amount of money. A calculator, you ask it to do an operation, it needs to perform. A radio, you set the radio to 97.1, it plays radio station 97.1. Vending machines, your telephone, pinball machines, video games, they all function like a function. So hopefully we can have a lot more discussion on this when we're live. The one thing I do want to point out, because it pertains to your video check-in, is the idea of open circles versus closed circles. So if you have an open circle directly above a closed circle, that passes the vertical line test. So when you're looking at the graphs on your video check-in, this closed circle includes this point, but the open circle does not include a point. So anytime you have an open circle and a closed circle directly above each other, that does pass the vertical line test. All right. Hopefully you guys are all set. It is a Kahoot, and have fun.